On the morning of April 7th, 1945, lookouts aboard the battleship Yamato spotted American aircraft on the horizon. The ships of Operation Tengo, Japan's last major surface sortie, had been steaming south through the East China Sea for nearly 24 hours. Vice Admiral Seiichi Ito stood on Yamato's bridge, watching the distant specks grow larger. He knew what was coming. Every man aboard knew what was coming. The Yamato was the largest battleship ever constructed. Her main battery consisted of 9 18-inch guns, the most powerful naval rifles ever mounted on a warship. Each gun could fire a shell weighing 3,200 pounds to a distance of over 26 miles. Her armor belt measured 16 inches thick at its maximum, tapering to nearly a foot across most of the hull. The armored deck added 9 inches of protection above the machinery spaces. She displaced 72,000 tons fully loaded, 73,000 tons counting. The fuel and ammunition she carried that morning. 3 years, 9 months, and 16 days had passed since her commissioning on December 16, 1941. In that time, she had fired her main guns at enemy surface vessels exactly once, during the Battle of Samar in October 1944. She had sunk 1 escort carrier, damaged another, and contributed to the sinking of several destroyers and destroyer escorts. This was the sum total of her combat effectiveness against surface targets. The ship that was supposed to decide the war in a single decisive battle had spent most of the war anchored, waiting for an enemy fleet that never came within range of her guns. Now, as the first wave of American carrier aircraft began their attack runs, Admiral Ito understood with perfect clarity what naval strategists had debated for 2 decades. The battleship era was over. The weapon that would sink his ship, the greatest battleship ever built, would be delivered by aircraft, launched from carriers he would never see, positioned beyond the horizon, beyond the reach of even his mighty 18-inch guns. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The irony was absolute. Japan had spent the better part of 4 years constructing Yamato and her sister ship Musashi. The 2 vessels represented the pinnacle of battleship design, incorporating every lesson learned from 3 decades of capital ship construction. They were meant to give Japan decisive superiority in the surface engagement that would determine control of the Pacific. But during those same years, from 1937 to 1941, the United States had been developing a different vision of naval warfare. While Japan poured resources into building the ultimate battleship, American planners were designing a class of fleet carrier that could be mass-produced with the efficiency of an industrial assembly line. The Essex-class carriers would prove faster to build, more versatile in combat, and far more effective at projecting power across the vast distances of the Pacific. By the time Yamato faced her final battle, the Americans had commissioned 17 Essex-class carriers. Another 7 were under construction or fitting out. The mathematical reality was stark. In roughly the same time it took Japan to build 2 super-battleships, America had launched enough carriers to establish complete air superiority across the entire Pacific theater. This was not a failure of Japanese engineering. The Yamato was a masterpiece of naval architecture, perhaps the finest battleship ever designed. This was a failure of strategic vision, a misunderstanding so fundamental that it cost Japan any chance of winning the war at sea. The question was not whether Japanese ships were well built. The question was whether Japan was building the right ships at all. The Yamato's design originated in the mid-1930s, when Japanese naval officers looked at the strategic situation and saw an impossible problem. The Washington Naval Treaty of 1922 had imposed strict limits on battleship tonnage and main gun caliber. Japan was allocated a smaller fleet than either Britain or the United States, set at a ratio of 5:3. For every 5 capital ships the Americans or British could build, Japan could only build 3. Japanese planners accepted this limitation during the treaty period, but they never accepted the strategic inferiority it implied. When the treaty system began to collapse in the mid-1930s, the Imperial Japanese Navy saw an opportunity. They would build battleships that individually outclassed anything the Americans or British could construct. Quality would compensate for quantity. The doctrine behind this thinking was called Kantai Kessen, the decisive battle doctrine. It envisioned a single massive engagement between battle fleets somewhere in the Western Pacific. Japanese battleships would use their superior range and hitting power to destroy American capital ships before the American numerical advantage could be brought to bear. This one battle would decide control of the Pacific. The doctrine had deep roots in Japanese naval thinking. It was influenced by Admiral Togo's victory over the Russian fleet at Tsushima in 1905, where the Japanese fleet had indeed won a decisive surface engagement that ended the war. It was reinforced by the writings of American naval theorist Alfred Thayer Mahan, whose books on sea power emphasized the importance of battle fleet supremacy. Every Japanese naval officer had studied Mahan. Many believed his theories with religious conviction. In November 1934, the Naval General Staff issued preliminary requirements for a new class of battleship. The specifications were ambitious. The ship would mount 18-inch guns, larger than any navy had ever deployed. It would have armor sufficient to resist 18-inch shells at battle range. It would achieve a speed of 27 knots, fast enough to force or refuse action. And it would displace no more than 69,000 tons, allowing it to pass through the Panama Canal if necessary, though this last requirement was quietly abandoned when designers realized it was impossible. The design process took 3 years. Engineers at the Naval Technical Department worked in absolute secrecy. Even the steel mills that would roll the armor plate were not told the true thickness of the material they were producing. The 18-inch guns were referred to officially as 46-centimeter weapons to confuse foreign intelligence. Every aspect of the project was compartmentalized. Yamato's keel was laid at the Kure Naval Arsenal on November 4, 1937. The construction slip had been modified specifically for this project, with taller cranes and reinforced foundations to handle the unprecedented weight. Enormous sheets surrounded the slip, hiding the work from observation. Guards patrolled constantly. Workers were forbidden to discuss any details of the project, even with their families. The ship grew slowly, immensely. The double-bottom structure alone required months of work. The armor belt, forged from special steel and face-hardened to maximum resistance, was installed plate by plate. Each turret, weighing over 2,700 tons, required its own barbette structure extending deep into the ship. The triple-bottom torpedo defense system consumed enormous internal volume, leaving less space for fuel and ammunition than designers had hoped. While Japanese workers labored in secret at Kure, American naval planners were engaged in their own strategic debate. They had also studied Mahan. They had also contemplated the decisive battle. But their conclusions were different, shaped by different geographic realities and different industrial capabilities. The United States faced a two-ocean problem. Any war would require fighting simultaneously in the Atlantic and Pacific. The fleet would need to project power across distances that made traditional battle line tactics problematic. America's industrial capacity could support mass production, but only if designs were standardized and simplified. The carrier had proven its worth in exercises throughout the 1930s. In February 1938, carrier aircraft from USS Saratoga executed a simulated attack on Pearl Harbor during Fleet Problem XIX, sinking, numerous battleships, and demonstrating that carriers could strike targets hundreds of miles from their position. The lesson was not lost on American planners, though it would be lost, tragically, on the defenders of Pearl Harbor 3 years later. By 1938, the Navy's General Board had concluded that carriers would be the primary striking arm of the fleet. Battleships would provide anti-aircraft support and shore bombardment, but carriers would find and destroy the enemy. This represented a fundamental break with the decisive battle doctrine, though many older officers still believed in battleship supremacy. The Essex-class design emerged from this strategic vision. The ships would displace 27,000 tons, well within treaty limits, that were still nominally in effect. They would carry 90 to 100 aircraft, a massive striking force. They would achieve 33 knots, faster than any battleship, and critically, they would be designed for rapid mass production. Unlike the Yamato, which required specialized construction facilities and techniques, the Essex carriers used conventional shipbuilding methods. The hull was welded rather than riveted, saving time and weight. The machinery was reliable but not exotic, using proven boiler and turbine technology. The armor was adequate rather than maximal, protecting vital spaces without the massive weight penalty of battleship-level protection. The first Essex-class carrier, USS Essex herself, had her keel laid on April 28, 1941, at Newport News Shipbuilding. Her sister ship Yorktown was laid down just 11 days later at the same yard. Intrepid followed in December. By the time Pearl Harbor was attacked, 4 Essex carriers were under construction. The attack accelerated everything. Within weeks, contracts were issued for additional carriers. Shipyards across the country prepared to build them. Newport News Shipbuilding in Virginia, Bethlehem Steel in Quincy, Massachusetts, Brooklyn Navy Yard in New York, Philadelphia Navy Yard, Norfolk Navy Yard, and the Fall River Shipyard in Massachusetts all received orders. The construction process was standardized to an unprecedented degree. Components were prefabricated and delivered to the yards for assembly. Welding techniques were refined to increase speed without sacrificing strength. Workers were trained in specialized tasks, becoming expert at specific jobs rather than general shipbuilding. The production line methodology of automobile manufacturing was applied to warship construction. Essex was commissioned on December 31, 1942, 20 months after her keel was laid. Yorktown commissioned in April 1943, Intrepid in August. By the end of 1943, 6 Essex-class carriers were in service. By the end of 1944, that number had reached 14. The 17th and final wartime Essex carrier, Philippine Sea, would commission in May 1945. The contrast in construction philosophy became evident in the details. Yamato's main turrets represented an engineering achievement unmatched in naval history. Each turret weighed 2,774 tons, more than an entire destroyer. The rotating mechanism required electric motors powerful enough to traverse this enormous mass smoothly enough for accurate fire control. The guns themselves, each weighing 165 tons, had been bored and rifled to tolerances measured in fractions of a millimeter. Loading these guns required a crew of over 60 men per turret, working in synchronized coordination. The shells, each weighing 3,200 pounds, were stored in magazines 4 decks below the turret and lifted by electric hoists. The powder charges, each weighing 770 pounds, came up in separate hoists. The entire loading sequence, from empty gun to ready to fire, took approximately 40 seconds under ideal conditions. In combat, with the ship maneuvering and taking damage, this time could extend considerably. The fire control system was equally complex. Yamato carried the most sophisticated optical rangefinders ever installed on a warship, with a baseline of 50 feet. The Type 94 fire control computer could calculate firing solutions, accounting for target speed, target course, wind, air temperature, and the rotation of the Earth. The system was accurate at ranges exceeding 25 miles under optimal conditions, but it was designed to engage surface targets, ships that moved predictably on a two-dimensional plane. Against aircraft, the system was nearly useless. The fire control computers could not track fast-moving aerial targets effectively. The main guns, designed to pierce battleship armor at extreme range, were far too slow to engage dive bombers and torpedo planes. Yamato carried an impressive anti-aircraft battery, including 12 5-inch dual-purpose guns and numerous 25mm machine guns. But these were defensive weapons, reactive rather than offensive. The Essex carriers embodied a different design philosophy entirely. Each ship carried approximately 90 aircraft in its standard air group, though this number varied throughout the war. The air group typically consisted of 36 fighters, 36 dive bombers, and 18 torpedo bombers, though these proportions shifted as tactical requirements changed. Each aircraft extended the carrier's offensive reach by hundreds of miles. A dive bomber could deliver a 1,000-pound bomb with reasonable accuracy from 200 miles away. A torpedo bomber could attack from similar ranges. Fighters could sweep enemy aircraft from the sky or strafe ground targets. The carrier's striking power was not measured in the size of its guns, but in the number of aircraft it could launch and the ordnance they could deliver. The flight deck was the key to this system. Essex-class carriers had wooden flight decks laid over steel structure, a design choice that saved weight and facilitated damage repair. The deck measured 872 feet long and 93 feet wide at its maximum. 2 H-4 hydraulic catapults assisted aircraft launches, though most launches were free takeoffs using the ship's forward motion and wind over the deck. The hangar deck below held aircraft for maintenance and storage. 2 elevators, each capable of lifting a fully loaded aircraft, connected the hangar to the flight deck. Aircraft could be struck below after landing, allowing continuous flight operations. This capability proved crucial in combat, where the ability to launch successive strikes without waiting for returning aircraft made the difference between destroying an enemy fleet and merely damaging it. Manning these ships required different skill sets. Yamato's crew numbered 2,500 men, most dedicated to operating the ship's machinery, handling ammunition, or manning the defensive weapons. The officers were battleship men, trained in gunnery, navigation, and surface tactics. Essex carriers carried crews of 2,600 ships company, plus the air group of approximately 2,000 officers and men. The air group included pilots, radiomen, gunners, ordnancemen, mechanics, and specialists of every description. These were not traditional sailors. Many had been civilians months earlier, trained rapidly in their specific roles, and integrated into the naval service. The training infrastructure required to produce carrier aircrews dwarfed anything Japan could sustain. American pilot training took approximately 1 year from enlistment to combat readiness. Students flew hundreds of hours in training aircraft, learning navigation, gunnery, bombing, and carrier operations. They practiced landings on training carriers in Lake Michigan, where crashes would not result in pilots drowning in the ocean. They studied recognition of enemy aircraft and ships. They learned radio procedure, formation flying, and tactical coordination. Japan's pilot training program, by contrast, had been reduced to months by 1944. Fuel shortages, limited flight hours. Aircraft were needed for combat operations rather than training. Instructors were pulled from training, duties to fill combat rosters. The result was predictable. American replacement pilots arriving at carrier squadrons in 1944 had skills comparable to veterans. Japanese replacement pilots were barely competent to find the enemy, much less engage in complex aerial combat. Yamato's first major operation came in June 1942, when she sortied as part of Admiral Yamamoto's force during the Battle of Midway. She never came within 300 miles of enemy ships. American carrier aircraft found and destroyed 4 Japanese carriers, while Yamato steamed uselessly far to the rear, her powerful guns silent. The battle demonstrated precisely what carrier advocates had argued. Aircraft could find and destroy targets far beyond the range of even the mightiest battleship. The lesson went unlearned. Japanese Naval Command continued to view Midway as a temporary setback, rather than a fundamental validation of carrier warfare. Yamato remained the symbol of naval power, the ship that would win the decisive battle when it finally came. That battle seemed to arrive at Leyte Gulf in October 1944. The Japanese plan called for multiple forces to converge on the American landing fleet, catching it between surface striking forces, while land-based aircraft attacked from Philippine bases. Yamato sailed as flagship of Admiral Kurita's center force, the most powerful surface formation Japan had assembled since the war began. On October 24th, while transiting the Sibuyan Sea, Kurita's force was attacked by aircraft from USS Intrepid, Cabot, and Essex, 3 of the carriers that had been commissioned since the war began. The strikes continued for hours. Yamato herself was hit by 2 bombs, causing minor damage and killing several crew members. Her sister ship, Musashi, the second Yamato-class battleship, was hit by an estimated 19 torpedoes and 17 bombs over the course of multiple strikes. Musashi capsized and sank, taking over 1,000 men down with her. Yamato survived, her heavy armor and damage control systems proving effective. But the attack demonstrated the fundamental problem with battleship-centered naval warfare. Kurita's force had no effective way to strike back. His anti-aircraft fire shot down some attackers, but could not stop the strikes. His ships could not maneuver fast enough to avoid torpedoes. His force was effectively helpless against an enemy positioned beyond visual range. The next day, Kurita's force broke through San Bernardino Strait and fell upon the American escort carriers of Taffy 3 off Samar. This was the surface engagement the Yamato had been designed for, battleships versus carriers at close range. Yamato opened fire with her main battery, engaging the escort carrier Gambier Bay and several destroyers and destroyer escorts that counterattacked with suicidal bravery. The action lasted approximately 2.5 hours. Yamato fired 104 18-inch shells, along with hundreds of rounds from her secondary battery. She sank Gambier Bay and contributed to the sinking of several escorts. But the action was indecisive. American aircraft from the escort carriers attacked Kurita's force, sinking 3 heavy cruisers. American destroyers and destroyer escorts made torpedo runs that disrupted Japanese formations and caused Kurita to maneuver defensively. Most critically, Kurita broke off the action and withdrew before destroying the remaining escort carriers, believing he faced a much stronger force than actually existed. For Yamato, this would be the only time her main guns engaged enemy surface ships. She had finally fought the kind of battle she was designed for, and the results were disappointing. The escort carriers she fought were small, slow conversions of merchant hulls, not the fleet carriers that represented real striking power. Even against these secondary targets, surrounded by only a handful of escorts, Yamato and her accompanying battleships failed to achieve decisive victory. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Essex carriers were experiencing a very different war. These ships operated continuously, launching strikes against Japanese positions from the Marshalls to the Philippines to Okinawa. They supported amphibious landings, providing close air support for Marines fighting ashore. They conducted anti-submarine patrols. They shot down Japanese aircraft by the hundreds during the Great Carrier Battles of 1944. At the Battle of the Philippine Sea in June 1944, 7 Essex-class carriers participated in what would be remembered as the Great Marianas Turkey Shoot. Japanese naval aviation, attempting to strike the American invasion force at Saipan, was annihilated. American fighters from the Essex carriers shot down 376 Japanese aircraft in a single day. Japanese air crews trained over months rather than years could not compete with American pilots who had trained for over a year and were flying superior aircraft. The disparity in construction time told its own story. Yamato required 45 months from keel laying to commissioning, from November 1937 to December 1941. Her sister Musashi took 41 months. These ships required specialized facilities that could not be replicated easily. The Kure Naval Arsenal, where Yamato was built, and the Mitsubishi shipyard in Nagasaki, where Musashi was constructed, were among the very few facilities in Japan capable of building such massive vessels. The third Yamato-class ship, Shinano, was laid down in May 1940, but construction was suspended after Midway. Work resumed in 1943 with a modified design converting her to an aircraft carrier. She was commissioned in November 1944 and sunk by the American submarine Archerfish 10 days later, having never conducted flight operations. The fourth planned Yamato-class ship was cancelled and scrapped on the ways. Essex-class construction times improved dramatically as yards gained experience. Essex herself took 20 months from keel to commissioning. Later ships were completed faster. Bunker Hill took 17 months. Hancock took 15 months. The yards learned to work efficiently, applying mass production techniques that steadily reduced construction time. Multiple yards building simultaneously multiplied the effect. In 1943, 6 different shipyards were building Essex carriers. In 1944, this had expanded to 7 yards. When one yard encountered delays, others continued producing ships. When workers at one facility developed better techniques, those techniques spread to other yards. The system was resilient, adaptive, and overwhelmingly productive. The resource allocation told the story in different terms. Yamato consumed approximately 72,000 tons of steel in her construction. Musashi required similar amounts. 2 ships consumed 144,000 tons of steel, plus the specialized armor plate that required special production facilities. Each Essex carrier used approximately 20,000 tons of steel. 17 carriers consumed 340,000 tons, more than twice what the 2 Yamato-class battleships required. But this comparison understated the true disparity, because the steel in an Essex carrier did more than the steel in Yamato. The carrier projected power through its aircraft, multiplying its effectiveness far beyond what tonnage alone suggested. The manning requirements revealed another dimension of the problem. Yamato and Musashi together required crews of approximately 5,000 men. These were highly trained specialists, many of them career sailors who had served for years in the Imperial Navy. Their training took years. Their expertise was difficult to replace. 17 Essex carriers required ships companies totaling approximately 44,000 men, plus air groups totaling approximately 34,000. Nearly 80,000 men operated these 17 ships, 16 times the manpower of the 2 Yamato-class battleships. But American training infrastructure could produce these men. Schools trained pilots, mechanics, radiomen, gunners, damage control specialists, and every other rating needed. The The system could replace losses, expand as needed, and maintain quality while increasing quantity. Japan could not match this. Japanese industry operated on smaller margins with fewer resources. Steel production peaked at about 7 million tons per year, compared to American production exceeding 80 million tons. Aluminum production, critical for aircraft construction, was measured in tens of thousands of tons in Japan, while American plants produced hundreds of thousands of tons. Oil supplies, restricted by American submarines sinking tankers, limited training and operations alike. The strategic situation by late 1944 made these disparities decisive. Japan had lost most of its trained naval aviators in the battles of 1942 and 43. Replacement pilots were inadequately trained and flying inferior aircraft against American pilots in superior planes. The carrier force had been essentially destroyed at Philippine Sea. Surface ships could not operate without air cover against an enemy with overwhelming air superiority. Operation Ten-Go was conceived in desperation. By April 1945, Okinawa was under American assault. The island was considered part of Japan's home territory, administratively part of Kagoshima Prefecture. Its loss would place American forces less than 400 miles from the Japanese home islands. The combined fleet had few operational ships remaining, but Yamato still represented enormous, symbolic value. The plan was simple because there were no good options remaining. Yamato would sortie with a small escort force, sail to Okinawa, beach herself on the coast, and use her guns as shore batteries, while her crew fought as infantry. The mission was one way. Fuel was allocated for the voyage south, but not for a return trip. Every officer involved understood this was a suicide mission, though the word was never used officially. On April 6, 1945, Yamato departed Tokuyama with a screen of the light cruiser Yahagi and 8 destroyers. The force had no air cover. Japanese naval aviation had been reduced to land-based kamikaze units that could not spare fighters for fleet defense. The ships would depend on their anti-aircraft guns and the hope that American forces might not detect them until they reached Okinawa. That hope was unrealistic. American submarines spotted the force almost immediately. Radio intelligence had already indicated a major sortie was planned. By the evening of April 6th, American command knew Yamato was at sea and heading south. Admiral Mark Mitcher, commanding Task Force 58, positioned his carriers for strikes at first light. The morning of April 7th dawned clear with good visibility. Yamato's lookouts spotted American aircraft shortly after 8 o'clock. The first strike arrived around 12:30. Aircraft from USS Hornet, Bennington, Belleau Wood, San Jacinto, and Essex began their attack runs. More carriers launched follow-up strikes. By early afternoon, nearly 400 aircraft were attacking the Japanese force. The coordination was methodical. Fighters suppressed anti-aircraft fire, strafing gun positions and forcing crews to seek cover. Dive bombers attacked from high altitude, their 1,000-pound bombs aimed at the superstructure and deck. Torpedo bombers came in low, releasing their torpedoes at ranges of 500 to 1,000 yards, close enough for reasonable accuracy, but far enough to avoid the worst of the anti-aircraft fire. Yamato's anti-aircraft batteries fired constantly. The 5-inch guns engaged bombers at altitude. The 25mm machine guns created walls of tracers around the ship. Gun crews worked their weapons until bombs killed them or fires drove them away. The ship's armor resisted the bombs reasonably well. Several hit without causing critical damage. But torpedoes were different. The first torpedo struck the port side amidships, then another, then several more in quick succession. Yamato's elaborate anti-torpedo defense system with its layered bulkheads and void spaces, absorbed the first few hits. But American torpedo bombers were concentrating their attacks on the port side, deliberately causing the ship to list in one direction. The tactic was standard doctrine, learned from sinking other battleships. Once a ship developed a significant list, its anti-aircraft guns could not depress or elevate properly, and its damage control became more difficult. By 1:30 in the afternoon, Yamato had taken at least 8 torpedo hits, all on the port side. She was listing 15 degrees. Counterflooding to correct the list would reduce stability dangerously. Captain Kosaku Aruga ordered counterflooding anyway, trying to keep his ship upright and fighting. The list decreased slightly, but more torpedoes hit home. At 2 o'clock, the list reached 20 degrees. Water was flooding into spaces that should have remained dry. The ship was losing stability with each new hit. Engineering crews worked desperately to maintain power, but flooding was reaching the boiler rooms. Main battery turret crews continued firing their anti-aircraft guns, though the list made aiming nearly impossible. At 2:05 in the afternoon, the list reached 35 degrees. Yamato was clearly dying. Admiral Ito had moved to the emergency bridge after the main bridge was damaged. He ordered all remaining crew to abandon ship. Many could not. The ship was listing too steeply. Men on the high starboard side would have to climb down the hull to reach the water. Men trapped below decks had no chance of escape. At 2:23, Yamato's forward magazine exploded. The detonation was visible for over 100 miles, a massive fireball rising thousands of feet into the air. The explosion broke the ship's back. The bow section separated and sank immediately. The stern remained afloat for several more minutes before sliding beneath the surface. Of Yamato's crew of 2,700 men, only 280 survived. Admiral Ito went down with his ship, as did Captain Aruga. Most of the crew drowned, trapped in flooded compartments or pulled under by the sinking hull. The escorting light cruiser Yahagi and 4 of the 8 destroyers were also sunk. The surviving destroyers rescued what men they could and returned to Japan. The Essex carriers continued their war. After the strikes that sank Yamato, they returned to supporting operations at Okinawa. They launched combat air patrols to intercept kamikaze attacks. They struck Japanese airfields on Kyushu. They covered minesweeping operations and provided close air support for troops fighting ashore. This was the routine of carrier warfare in 1945, repetitive and exhausting but overwhelmingly effective. Several Essex carriers were hit by kamikazes during the Okinawa campaign. USS Bunker Hill was struck by 2 aircraft on May 11th, killing 396 men and causing severe fires. The ship survived and was repaired, though not in time to return to combat. USS Franklin had been hit earlier, in March, suffering over 800 casualties, but remaining afloat through extraordinary damage control efforts. USS Hancock was damaged. USS Intrepid was hit multiple times across different campaigns, earning the nickname Evil Eye from Japanese pilots who seemed to target her repeatedly. But damaged carriers could be repaired. Dead airmen could be replaced. Lost aircraft could be built in weeks. The industrial system behind the Essex carriers absorbed losses that would have been catastrophic to Japan and continued operating at full capacity. This was the decisive advantage, not in vulnerability but resilience backed by overwhelming productive capacity. When Japan surrendered in August 1945, 13 Essex-class carriers were operating in the Pacific. 4 more were in American waters, completing repairs or training. The class had lost no ships to enemy action, though several had been severely damaged. They had participated in every major campaign from 1943 onward. Their aircraft had sunk dozens of Japanese warships, destroyed thousands of Japanese aircraft, and supported amphibious landings from the Marshalls to Okinawa. The carriers continued serving long after the war ended. Most were placed in reserve in the late 1940s as the Navy demobilized. Many were recommissioned during the Korean War, their Pistons aircraft replaced by jets, their capabilities updated for a new era of warfare. Several served through the Vietnam War, launching combat missions decades after they had been commissioned. The last Essex carrier on active service was USS Lexington, which served as a training carrier until 1991, exactly 50 years after the class first entered service. She is now a museum ship in Corpus Christi, Texas. Several other Essex carriers survive as museums: Yorktown in Charleston, Intrepid in New York, Hornet in Alameda. Visitors can walk their decks, see the ready rooms where pilots briefed before missions, stand on the flight decks where aircraft launched for combat. No trace of Yamato remains accessible to visitors. The wreck lies in nearly 1,200 feet of water east of Kyushu. The ship broke into multiple sections when the magazine exploded. The bow and stern rest separated by hundreds of yards. Japanese survey. Expeditions have located and documented the wreck, but it remains a war grave, undisturbed and protected by Japanese law. The contrast in fates reflects the contrast in strategic value. The Essex carriers were useful ships that served for decades because their design was sound and their capabilities relevant. They adapted to new technologies, accommodated new aircraft, and remained effective long after the war that spawned them. Yamato was obsolete before she was completed, a magnificent answer to a question that no longer mattered. Japanese naval officers who survived the war and wrote memoirs struggled with this reality. They had believed in battleship supremacy with genuine conviction. They had studied Mahan and Togo and drawn reasonable conclusions from the evidence available to them. They had designed and built the most powerful battleship ever constructed. None of this mattered because the fundamental premise was wrong. Admiral Matomi Ugaki, who survived the war only to die in a final kamikaze mission the day after the surrender, kept a detailed diary throughout the conflict. His entries from 1944 and 45 show increasing awareness that Japan was losing not just battles, but the technological and industrial competition. He noted American radar capabilities, American damage control, American replacement rates for lost ships and aircraft. He understood that fighting spirit could not overcome material disadvantages of the scale Japan faced. Other officers reached similar conclusions. Captain Tamechi Hara, who commanded destroyers throughout the war and survived, wrote extensively about the disparity in resources. He described watching American task forces operate with casual abundance, while Japanese forces scraped by on minimal fuel allocations. He noted that American ships damaged in battle were often repaired and returned to service, while Japanese ships with similar damage were abandoned for lack of repair capacity. The strategic implications extended beyond naval warfare. Japan's decision to build Yamato and Musashi represented a broader pattern of resource allocation that contributed to defeat. The steel, machinery, and labor that went into the two battleships could have built dozens of destroyers or hundreds of aircraft. The crews that manned them could have served in more useful capacities. This was not obvious in 1937 when Yamato's keel was laid. At that time, the battleship still seemed like the ultimate expression of naval power. But by 1941, when Yamato was commissioned, carriers had already proven their worth. By 1942, after Coral Sea and Midway demonstrated that carrier battles would decide the Pacific War, continuing to devote resources to battleships was strategic malpractice. The American decision to mass-produce Essex carriers represented clearer strategic thinking backed by superior industrial capacity. American planners recognized that carriers would be the decisive weapon. They designed a carrier that could be mass-produced. They built the industrial infrastructure to produce them in quantity. They trained the personnel to operate them. They integrated them into a coherent operational system that projected power effectively across vast distances. The result was inevitable. By late 1944, the American Pacific Fleet operated with overwhelming superiority in every category. More ships, better ships, more aircraft, better aircraft, more trained personnel, better logistics, superior radar and communications, and industrial backing that could replace losses faster than Japan could inflict them. Yamato's sinking merely confirmed what had been true since Midway. The battleship era was over. The decisive battle Japan had planned for would never occur because American carriers would never allow Japanese battleships to close to gun range. Air power projected from mobile platforms hundreds of miles away had made the most powerful naval rifles ever built irrelevant. The 3 years from late 1937 to late 1940 represented roughly equivalent construction periods for Yamato and the first 10 Essex carriers. In that time, Japan built one of the 2 most powerful battleships in history. America built the foundation of the carrier force that would dominate the Pacific for the rest of the war and beyond. The numbers told the story. 2 battleships versus 10 carriers, which later became 2 battleships versus 17 carriers. 72,000 tons of Yamato versus 340,000 tons of Essex-class hulls. 9 18-inch guns versus approximately 1,500 carrier aircraft. 2,500 crew on Yamato versus 40,000 ships company and 34,000 aviators on the Essex carriers. But the true disparity was not in the numbers themselves. The true disparity was in strategic flexibility. Yamato could only fight the kind of battle she was designed for: a surface engagement at gun range. When that battle never materialized, she was useless except as a symbolic target. The Essex carriers could fight any kind of naval battle, strike enemy ships at ranges exceeding 200 miles, support amphibious landings, conduct anti-submarine warfare, intercept enemy aircraft, attack shore installations, mine harbors, conduct reconnaissance. They were adaptable tools that could be employed in whatever manner the tactical situation required. This flexibility, backed by industrial capacity to build carriers in quantity and train aircrews to operate from them, proved decisive. Japan's leadership had bet on quality over quantity, on the decisive battle over sustained operations, on traditional naval power over emerging technologies. Every assumption proved wrong. Every decision based on those assumptions contributed to defeat. The morning of April 7th, 1945, when Admiral Ito watched American aircraft approach, his doomed ship represented the final proof of strategic failure. The most powerful battleship ever built, steaming on a one-way suicide mission, armed with guns that would never fire at an enemy surface vessel again, about to be destroyed by carrier aircraft launched from ships positioned safely beyond the horizon. The mathematics of victory had been calculated 3 years earlier, when Japan laid down 2 battleships and America began building 10 carriers. The rest was merely confirmation. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.